Hey all, welcome to Homeschool and welcome back to Class 11 Physics series. Today I am with one of the most requested chapter, very simple chapter, that is the physical world, chapter 1 of Class 11 Physics. See, two chapters I have already completed. Video playlist links are provided in the description. You can go and check it out if you have not yet watched. See, I have completed units and measurements as well as one of the very important chapter, motion in straight line. And coming to this chapter, this is very simple chapter. So I am covering all the concepts of this chapter in a single video. So this is going to be quite a lengthy video, but then all concepts are covered in a detailed way. Fine. So what we study in physical world? We will try to understand the exact meaning of physics. So what actually physics is meant for? What we study in physics? How do we study physics? I mean, not only physics. Usually, any natural phenomena that is there in our nature is studied in a certain method, which we call it as scientific method. Okay, so we will discuss about scientific method, and we will also discuss about scope and excitement of physics. So what is the scope, importance of studying physics, and what excites us in the study of physics? All of that with simple examples we will try to understand. And not only that, the very important concept of the chapter is learning about natural forces. So there are some fundamental, basic and natural forces in our nature, like gravitational force, nuclear force, all forces we will try to understand briefly. And then there are certain laws governing various natural phenomenon. Okay, so we will briefly discuss about the different laws. Clear? Fine. And coming to the very first aspect of this chapter, there are many things happening around us. For example, many natural phenomena kept on happening around us. Thinking of these natural phenomena, we wonder how and why this happened, right? For example, sunset and sunrise. So why do sunrise? Why do sunset? Why this concept of day and night? Right? And how does this earth rotate around sun? And how do moon rotates around earth? What makes them rotate? How do they move? Right? And not only that, the beautiful rainbows, when we see, why do rainbow can be seen, right? So how does rainbow appear? So why is the sky blue? And how can we see various things when there is a light? When there is no light, we cannot see anything, right? And how do these seasons changes, summer after winter and spring, why the seasons kept on changing? And the tides, how do you get tides in the ocean? Like that, there are n number of wonders every day that we observe in our nature, right? And now we do have answers for all these questions, right? And science is all about learning these things. And you know what? In the olden times, man was not knowing all these things. Actually, these were the curious things. This is what created a curiosity in man to invent new things. And because of his curiosity, many things were invented and we are comfortably living on this earth, right? And you know what? Science is all about learning all these things I told you. So actual meaning of science, this science, the word science is actually a Latin word, which means, science means to know. Science means to know something. Okay, so whatever happens in our nature happens for a reason, and you must know the reason behind that. Science is something to know, right? So the Latin meaning of science is to know. And Coming to our Indian language, we call science as Vignan, right? So Vignan means what? Vignan means knowledge. So science also means knowledge. So something about the natural phenomenon we are trying to understand. So that is all about the science. And there are various branches of science, and one such branch of science is physics, right? So what actually we mean by physics? Physics is a branch of science that deals with study of natural phenomena. Okay, so we study many natural phenomena that are taking place around us. Like I already told you, sunset, sunrise, and we study about optics. We study about how planets move, and how the stars twinkle. How does a rainbow appear? All these are natural wonders, right? So physics is all about study of natural phenomena. Okay, with the help of certain natural forces, right? So there are certain natural forces existed in our nature, right? So with the help of these natural forces, natural laws, we are trying to understand natural phenomena that takes place in a nature. So this branch of science, we call it as physics, right? Okay, so every natural phenomena, whatever you want to study, must be studied in a systematic way. Okay, and that method of study, we call it as scientific method. Okay, so now let us try to understand what do you mean by scientific method. So what do you mean by scientific method here? So scientific method is a proper method. Okay, so it's a proper protocol that we have to follow to understand any natural phenomena. Okay, so scientific method involves certain steps, right? So whichever natural phenomena that you want to study, you must study with proper steps. Okay, so with a proper method. So that method is scientific method, and it involves certain steps. Okay, so let us try to understand what are those steps. The first one, step number one. First, we need to observe the natural phenomena, right? So, which I call it as systematic observation. Systematic observation. So, any natural phenomena, if you want to understand, first you must able to observe it carefully, right? And later, we must do controlled experiments. We have to do many experiments on that natural phenomena, right? And the third step is qualitative and quantitative reasoning. Qualitative and quantitative reasoning. Okay, I'll explain all these things with the help of one example. Don't worry. Okay, so once you do experiments, you have to analyze your observation. Okay, so how much quality you have in your experiments. I mean, whether you can quantify that in a mathematical relationship or not. So everything we have to able to understand. Okay, so that's what we mean by qualitative and quantitative reasoning. So you will understand when I give example, don't worry, just copy it down. And the fourth step is mathematical modeling. Mathematical modeling. Okay, so once you have discovered something, you must able to give certain equations. For example, nature of light, electromagnetic radiations have certain equation, right? Say, which we call it as E is equal to H nu, E is equal to MC square, and there are various formulas, right? Say, actually, after learning a particular phenomena, they have come to one conclusion, and that conclusion was expressed in some mathematical formulas. Okay, so that's what we mean by mathematical modeling. Okay, so after that comes the next step, prediction. We must able to predict the phenomena carefully, and finally comes our verification, falsification of theories. Okay, so actually these are the different steps that includes under scientific method, right? For example, imagine you want to understand how our earth moves around the sun. Okay, say in what pattern, in what way our earth can move around the sun. This is what the natural phenomena you want to study. So first what you will observe, first thing is you must observe at what time the sunrise and sunset takes place. Okay, say for example, you fix it for the sunset. So exactly evening at 4 o'clock, try to take pictures of sun from one particular place. Select one particular place, there you fix a camera, always at 4. Okay, so every day around 1 year at 4 p.m. from a particular place, you fix a camera and try to take the photographs of sun, okay, during sunset. Okay, so do it like this every day for 1 year. That's what you are actually observing the position of sun from earth, from a particular place. So this is what I mean by observation. You're observing every single day with that photograph. You are observing how the sun will not move, earth will move. That's what you are observing, the timing of sunset, right? Fine. And later, see you are continuing your experiment for 1 year. This is what every single day you do this observation, right? So that's what we mean by experiment. Okay, so systematic observation. After that you have to conduct several experiments, and then you know what, after observing the sun's position every day at 4 p.m. you will observe, if you combine all the pictures of 1 year, you get something like this. Okay, say one day sun was here, the next day sun was here, the next day sun was here. You know what, something like this. That means this proves that actually your earth moves in a elliptical way around the sun, right? If you join all these points, imagine first day sun was here, second day sun was here, third day sun was here, like that 365 days when you kept on finding the position of sun during sunset, you get when you join that points, you get a shape like this. So this will tell that your earth is moving in a elliptical way around a sun, right? Say, how did you come to know? This is what you have come to some conclusion. And to explain this phenomena, if you are giving certain mathematical formula, see, mathematical formulas always helps us to understand the things in the easiest way. Okay, so you can correlate different things with one formula, right? Say this is what we mean by mathematical modeling. And what about qualitative and quantitative? Like, you know what, here you can check the quality of the experiments that you have done have to be monitored, and the number of days, that is the quantity, like how long you have conducted the experiment, all the qualitative aspects of your experiments and quantitative aspects of your experiment have to be reasoned properly. They have to be monitored properly, and they have to be explained properly. All quantitative and qualitative aspects. After that, you must, if possible, you can give a certain mathematical relationships to understand better. To convince other people in a better way with mathematical equations, right? So that's what comes under mathematical modeling. And after that, after learning about certain natural phenomena, think that whether you can predict something else or not out of this. Okay, and after that, a certain level of verification, proving, and you have to prove that this is true for people, right? And people must verify whether this is true or not. So verification have to be done, and if any limitations are there in your experiment, that falsification, if it is going out of the logic, then falsification of theories, we say it is a false theory, right? So whether it is true or false, that have to be decided at the end after verification, right? So this is what the explanation of these steps, guys, nothing much. So all these steps are included in scientific methods. If you are studying a particular natural phenomena, it has to be studied in a systematic way, and that way is what we call scientific method, right? Okay, so this is our first concept. And coming to the second concept, two principal thrust in physics. There are two thrust in physics. Let us see what do you mean by those thrust in physics. See, as I already told you, physics is all about studying natural phenomena that is taking place in our nature. And when you study a particular concept, it can be studied in two ways. There are so many natural phenomena that is taking place in our nature. Physics is actually very vast, very deep aspect. There are so many things to learn, right? And few things are very difficult and few are very, very easy, right? And it can be studied in two ways. That's what we mean by principal thrust. There are two principal thrust. I mean, you can study the concept in two different ways, right? So what are the two principal thrust in physics? The first one is unification. We call it as unification. And the second one is reductionism. Reductionism, or you can just call it as reduction. See, as the name only says here, unification. I mean, small principles or small laws can be combined together and studied as one single theory. Okay, so unification means what? Small laws or principles can be combined and studied as one single law or theory. This is what we mean by unification. Okay, say for example, when I throw this chalk piece onto the air, will it stay on the air? No, it will fall onto the ground. Why? You all will say it's due to gravity, right? And what about the rotation of moon around earth? Why do moon rotate around earth? And you know what? How do earth can rotate around sun? It's all due to something called gravity. It's all due to certain forces. Okay, say there is a small law for telling why this chalk piece falls on the ground, and there is a law for telling why moon can rotate around earth, and there is a law for telling why earth rotates around sun. But commonly all of them follow a law of gravitation. Okay, so here study of an object falling on earth, study of rotation of moon around earth, and the rotation of earth around sun, all of them are different concepts, actually different small laws, but all of them are studied together as law of gravitation. So all of them have something connected to gravity. So in the law of gravitation, in the theory of gravitation, we discuss all these small principles, right? So that means different small aspects which are common can be combined together and studied as one single theory, so that our study will become more convenient and comfortable, right? So this is what we mean by unification. Okay, say what do you mean by reductionism? Reductionism is opposite, guys. Say for example, thermal physics is there. There is something called thermal physics. Okay, so this thermal physics is very vast. Thermal physics means you are actually studying the heat content of certain substances, right? So the heat issues regarding certain substances. And you know what, you can't study this at a stretch. You have to divide this into different branches first. You know what, first we will study something called thermal properties of matter. Okay, thermal properties. It's a very, very vast branch where we can't study at a stretch. We again divide this into subtopics, like thermal properties we study. Then we study something like thermodynamics. Thermodynamics is one of the small branch of physics. And we also study kinetic theory of gases. Kinetic theory of gases. You know, this is a very vast concept. At a stretch you can't study, so we can split into small topics and study. You know, this also makes our things much easier, right? So both physics can be studied by unification or by reductionism. So unification and reductionism are two principal thrusts in physics. Okay, so what is the definition I can give for reductionism? You know, complex theories or concepts can be divided into small theories. Okay, can be divided into small concepts for study is called reductionism. Okay, so both are actually opposite terms, and here in the unification many small principles we are combining and we are studying as one single theory. Okay, so that is for easy purpose. And here also something which is very much complex, something that we cannot study as so big, we are breaking into small parts and we study in a individual way. Okay, so why this unification and why reductionism? It is to understand better about the natural phenomenon. Okay, so that's why we call unification and reductionism are the two principal thrusts in physics, right? Okay, so this was the second concept that we have finished. Coming to the third concept, let us discuss about scope and excitement in physics. Say students, we study physics in two particular domains. One is microscopic domain, the other one is macroscopic domain. I mean, about macroscopic object we study in classical physics. Okay, actually there are, you know, two ways physics can be divided. One is the concepts of classical physics. We have something called classical physics, and we also have quantum physics. So this is really very important, quantum physics. Okay, you will study about this more in higher classes. So most of the things that we study for class 11 and class 12 come under classical physics. So classical physics involves the study of macroscopic objects. Okay, say the forces or the laws that govern macroscopic object. I mean, for example, if I have to move this board, you know, board is a very big object, right? It's a macroscopic object. If I have to move this, I need to apply some force. So the concept of force, the concept of pressure, whatever it may be, whatever the laws that is associated for the movement of this board will come under classical physics. Okay, so whatever you study about macroscopic object, whatever the laws or theories involving in studying them, all of them will come under classical physics. Okay, say for example, study of you know, big celestial bodies like stars, planets, galaxies, you know, all of them will come under classical physics. Say classical physics involves the branches or topics like mechanics, electrodynamics, okay, then thermodynamics. You know, all these are actually branches of physics, guys. These are all various topics or concepts of physics which you will study in the later chapters actually. Okay, so all of them, all these branches will come under, you know, classical physics, thermodynamics and optics. So you know something about optics, right? Say reflection, refraction, lenses, mirrors, it's all about so-called optics. It comes under a branch called optics. So what do we study in these branches? We study some laws about macroscopic object, big objects. Okay, so those aspects will come under classical physics. And coming to quantum physics deals with the forces and laws involving microscopic objects, microscopic particles I can write. Okay, for example, electrons, protons, all these are microscopic particles. Okay, so actually we can call electrons as matter waves also. So about a matter wave you will study more about these things in the later chapters, don't worry. Okay, so what are the forces or laws that govern the matter waves? Matter waves is nothing but electrons. Okay, so the movement of electrons, the nature of electrons, the attractive forces that govern electrons, all of them about microscopic smallest particles we study under quantum physics. So this way various branches or topics are studied in two different types of physics. Actually, one is a classical physics and quantum physics. Actually, classical physics is a very conventional topic. I mean, from the olden times onwards, we are following this classical physics, and quantum physics is a recently evolved physics. Okay, so actually both physics are just opposite. Both the concepts in classical physics and quantum physics is actually opposite to each other. Anyway, most of the differences and the similarities between these two you will find it in later chapters or in much higher levels. Okay, and let me excite you by saying this information, and let me give a piece of curiosity for you in understanding these things. See, just try to understand, physics is a very vast subject where you learn about many things. Okay, when you learn about many things, we use certain physical quantities. Okay, so when we study some concepts, we use some tremendous physical quantities. Okay, what do you mean by physical quantities? Physical quantities are nothing but the length, right? Physical quantities like length, mass, we have something called energy, time. All the concepts, all the natural phenomenon can be explained with the help of these physical quantities like length, mass, energy, time, etc. There are many more physical quantities actually, right? See, just try to observe, length. If you come to a length, what ranges of lengths that you will study in physics? Range of length I'm giving you. We study lengths as small as 10 power minus 15 meters to length as big as 10 power 26 meters. 10 power minus 15 meter, this is actually, this number you will find for the size of a nucleus. We all know the atom, right? Atom has nucleus at the center, electrons revolve around the nucleus. How much is the size of nucleus? 10 power minus 15 meters. Size of nucleus is this much. I mean, when we talk about length, when we measure the length of something in physics, we can measure very small lengths and we can measure very big lengths. We can measure the small length as small as this number, 10 power minus 15 meters. For example, this is the size of nucleus, and 10 power 26 meters is the size of universe. Okay, see, for example, universe is actually limitless. There is no end. Universe means the known boundary. Like, what is the known boundary for universe currently in the present situation? That I consider as universe. Okay, so size of universe can be 10 power 26 meters. Huge. It's a huge number, right? So we measure lengths as small as this number and we measure lengths as big as this number in our physics. Similarly, let me give you range of mass. Range of mass. We can measure the mass as small as 10 power minus 30 kg. You know, this is the mass of electron. This is the mass of electron. And we can measure the mass as big as this much number, 10 power 55 kg. And this is the mass of universe. Mass of universe. See? Say this to this much extent we can measure something about the objects. Okay, and next let me give you the range of time. Isn't it exciting to know about all this, right? So we can measure so much small numbers and very much high numbers also. So range of time, we can measure the time as small as 10 power minus 24 seconds. You know, this is actually the lifetime of elementary particles like neutrino. There are certain particles called neutrino. What do you mean by neutrino? You know, during beta decays, there are certain small particles gets liberated. Okay, you will observe certain small particles and they don't exist much time. They will die very soon. You know, their lifetime is about these many seconds. That is 10 power minus 24 seconds. Okay, so and you can measure time as big as 10 power 17 second, and this is actually a lifetime of universe. Okay, see, this is something that excites, you know, a person to understand. You know, we can measure as small as this and as big as this, and you know, in this range, all lengths we keep measuring, all masses, all sorts of masses we measure, all sorts of times we measure. You know, with the help of these physical quantities, we can understand a particular law or theory in a better way about many natural phenomena. Okay, so this comes under the heading, you know, scope and excitement of physics. And now we will go for very important topic of this chapter actually, that is the fundamental forces that exist in our nature. Look at this, guys. This is quite important thing to remember. Okay, so this is quite an important topic of this chapter, I can say. The fundamental forces in nature. So there are, see, physics is all about learning these forces, understanding these forces, and how these forces can act on microscopic object, that is smaller object, or bigger object, that is macroscopic object. So there are four fundamental forces in our nature. First one, gravitational force. Second one, weak nuclear force, electromagnetic force, and strong nuclear force. So these are the four fundamental forces exist in our nature. So let us understand where we find gravitational force. Okay, so here I have a column of relative strength. Say relative strength tells you about which force is strongest and which force is weakest. Okay, you can see here among all the forces, you can see a value 1 for strong nuclear force, right? So strong nuclear force is always strongest. This is the strongest force in our nature. Which is the strongest force in our nature? Strong nuclear force. Whereas you see the relative strength, I mean comparing to one force, what is the value, what is the strength of this force? You know, that's what we mean by relative strength. We are comparing the strength of these forces, the strongness of these forces in our nature. Okay, so the strongest force is strong nuclear force. And the weakest force is gravitational force. You can see the relative strength value 10 power minus 39, right? So this is the weakest force. And coming to 10 power minus 13 for weak nuclear force. And 10 power minus 2 is for electromagnetic force. After strong nuclear force, next strongest force you can find is electromagnetic force, because you see the value. So this actually tells you a comparison. This explains about a comparison of strength between these four forces. Okay, so among them strongest is this and weakest is gravitational force. Okay, so now coming to the range and description. Okay, so where do we find gravitational force? Gravitational force is always found between all objects which has mass. Okay, so even between you and me also there is a gravitational force acting. So between us and earth there is a gravitational force. So gravitational force is between any object. If this is one object, this is another object, where they are placed with certain distance r. You know, this has got mass 1 and this has got mass m2. Okay, so between these two objects you will observe a force which we can call it as gravitational force. Okay, say it can be whatever may be the distance. The distance can be little or distance can be far away. You know what, I am standing here but I don't know where you are sitting, in which city, in which place you are sitting, but then between you and me there is a gravitational force. May not be too much big, but little of gravitational force may act upon between us. Okay, so that's what we mean by the range of gravitational force is infinite, or we can also call it as long range force, because I told you, no, between any two bodies there can be a gravitational force irrespective of the distance. Distance can be quite long, very long, but then between them there exists a force called gravitational force. Okay, so that's why we say the range is infinite. Okay, and then this is actually an attractive force and this is a weakest force, and you see gravitational force is inversely proportional to r square. R is what? Distance between the two objects. R is distance between two objects. So these two objects, between them if the distance is least, then gravitational force will be stronger. Okay, so gravitational force strength depends on the distance between the object. Okay, fine. So that's all about gravitational force. And coming to weak nuclear force, and this is a very short, I mean it also observed between the particles only. It's like not too many big objects. It is always observed between elementary particles. Elementary particle means you know, neutrinos. I told you about neutrinos, right? During beta ray decays, you know, you will observe certain particles called neutrinos, and they don't live for a longer time, just like electrons. Okay, just like electrons, protons, you have something called neutrinos. So between these smallest particles, between electron and neutrino, there can be a force, you know, that force we will call it as weak nuclear force. And you know, this is a very short force. Okay, so if you want to observe this force, you know, there must be a very little distance between the elementary particles. So that's why we say it is a very short range. And coming to the third force, electromagnetic force. Electromagnetic force is observed between the charged particles. So any two bodies when they have a charge, okay, so between them you will have certain forces called electromagnetic force. And this electromagnetic force can be attractive or repulsive. You know, you must identify the major difference between gravitational force and electromagnetic force. Gravitational force is always attractive, but electromagnetic force can be attractive or repulsive. So we all know, when you place two objects of same charge, you know, you would observe the repulsion. When you place objects of opposite charge, you will observe attraction. So it depends on what charge the bodies have. You know, you will observe either attraction or repulsion. Okay, so we say electromagnetic force can be attractive or repulsive. And even this electromagnetic force can be inversely proportional to r square. What is this r? It is the distance between the object. So if the distance is small and then electromagnetic force experienced can be higher. Okay, so and even this is infinite. Wherever maybe the objects, it can be quite far away, but then you will observe certain force, that is electromagnetic force. So that's why we say, just like gravitational force, even our electromagnetic force is infinite or long range force. Okay, so experienced, this force is experienced between the bodies which are quite far away. Okay, fine. And coming to strong nuclear force. So where do you observe this strong force? It is between nucleons. So what do you mean by nucleons? Nucleons, in the sense, it is between protons and neutrons. Protons and neutrons. Inside the nucleus, we have protons and neutrons, right? So between protons and neutrons, there is a very, very strongest force, which we call it as strong nuclear force. Okay, and even this is a short range force. I mean, to observe this force, there shouldn't be too much distance between protons and neutrons. They have to be very, very close with each other. Only then you can observe the strongest force between them. Okay, so that's what we mean by short range force. Okay, so hope every information is clear about. So this is quite an important information from this particular chapter. So what are the four types of fundamental forces and their description? Where do they present, between what objects, what type of objects you will observe them, and what is their range and what is their relative strength? Okay, so this is quite important. And now we will go for the last concept of the chapter, that is some fundamental laws. See guys, all natural phenomena that happens in our nature must follow certain conservation laws. Okay, so let us discuss about conservation laws. So they are called as basic laws or natural laws. Okay, say for example, you have water falling from a tap, right? Say water, you have a stored water. Say in this tap, you actually have some stored water, right? So stored water has some energy which I can call it as potential energy, which I can call it as potential energy, right? Okay, so I want to fill this water in a bucket. You know, the stored potential energy, the moment I on the tap, the water fall into a bucket. This stored potential energy is getting converted into kinetic energy. Okay, and later the water gets settled on this particular container or bucket. So again this kinetic energy is converted as potential energy, right? So here whatever the energy was there with water, that was conserved, that remained constant. The word conservation means what? Something that is remaining constant. Okay, so you haven't destroyed energy, you have not created extra energy, you just converted one form of energy into another form of energy, but at the end what you can say is energy is conserved. So every natural phenomena, guys, every natural phenomena must follow some conservation laws. So there are some conservation laws. Say the first one is conservation of energy mass, conservation of energy or mass. Okay, so energy is always constant. You can only change the energies of something from one form to another form, but energies have to remain constant. You will observe this in all natural phenomena actually. And similarly mass have to remain constant, right? So that's what we study in conservation of energy mass. This is one conservation law. And the next one is conservation of momentum. Conservation of momentum. Okay, so momentum is what? Mass into velocity. Say momentum is a property for a moving object, right? So when an object is under movement, there are so many factors associated with it. Whatever the factors, everything must must be conserved. I mean, they must remain constant. And the next conservation law is conservation of angular momentum. See, about all these terms you will study in later chapters, don't worry. So just I'm mentioning, understand the overall picture that whenever some natural phenomena takes place, the energy, the mass, the property like momentum, the property like angular momentum, all remain conserved, all will remain constant. Okay, only thing is they can convert from one form to another form, but at the end they remain constant. Okay, so this is what a small introduction or the brief things about the conservation laws. Okay, nothing much to study except this, right? So this is all about the chapter, guys. So among all the topics, one important topic is that types of natural forces like gravitational force, nuclear, weak nuclear force, strong nuclear force, and electromagnetic force. Whichever points I mentioned on about, that is quite important. So nothing much to worry about this particular chapter. So that's all about the chapter. With this, I have completed all concepts of physical world. And in my next session, let me start with the fourth chapter of physics, that is motion in plane. And to understand that chapter, you must have certain basics in mathematics. Before that, let us learn about calculus and then differentiation. After learning these aspects, let's go for learning motion in plane. It will start with vectors, right? So if you have to understand motion in plane, you must have an idea about vectors. So let's learn all of them one by one in a detailed way. Thank you so much. Do subscribe our channel to learn in the best possible way and share the videos with your friends also. All the best. Meet you all in the next video. Thank you so much.